All right, so in Chapter 8, Section 2, the two-step stuff. We've been solving two steps already with our models, with the bar diagram, some tiles, but basically we've been talking about how do you undo this equation? How do you take an equation and take it apart so that you're left with the value of the variable, the isolated value? And that's what we're going to talk about today, is how do we demonstrate the process for undoing these equations. Now, I have to change something. In your notes here, yours says method number 1, vertical, I believe, right? Yeah. Change method number 1. Write algebraic instead of where yours says vertical. And then underneath that, where it says horizontal, change that to table. I'm going to, method number 2 will be the table, equation tables we call these. My goal is going to be to present you with a couple of different ways that you could demonstrate how to undo an equation. One of those is algebraic, the other way is the table. You can pick whichever way you like. I just need you to be able to show me how that variable came to be all by itself. Like it starts off where it currently is. Where did all the other stuff go? We need to validate that through mathematics. That's what we're going to practice today. So the first equation, I have 0 doubts. You guys can tell me what the value of m is right now, or if not right now, very quickly. But I don't want to know what it is yet. I want to focus more on how to take it apart and show that, okay? I'm assuming everyone in here would want to do the exact same thing first. If you're taking this thing apart, what's the first step that you're going to do to undo this thing or disassemble it, however, whatever analogy you want to use? Brock? 32 plus 8, we add 8 to both sides. Undo it. What's the inverse of that, Brock? So we want to do the opposite of what's happening, or the inverse of what's happening currently, right? So we have, it's being, 2m is being added to 8, or 8 is being added to 2m, however we view it. What would I do as the opposite of adding 8? We're going to take away 8, and that's exactly what we're going to do. But we're not only taking away 8 from the 32, which most people would just say, oh yeah, do 32 minus 8. Yeah, I understand that. 32 minus 8 is 24. However, if you don't tell me to take 8 away from 8, then when you rewrite this equation, technically you're telling me that 2m plus 8 now equals 24. And it doesn't. Because how could 2m plus 8 equal 32 and then turn right around now 2m plus 8 equals 24? You've changed the equation. So what do we need to do as thorough students here to show what happened to the 8? Sarah? Show it, exactly. So there, that demonstrates. And you can prove to people that say, well, where did the 8 go? I don't get it. Well, we subtracted 8 from 8. And that addition, subtraction property of equality that we've referenced before, whatever you do to one side, if you do the exact same thing to the other side of the equation, it remains unchanged. So this now is saying 2m equals 24. You balance the equation. Great. M isn't isolated yet. Fix that. Andrew? 2m divided by 2. So 12. What are we left with over here, Andrew? 1m, right? And I'll just put m because the 2's cancel. And m is 12. work doesn't have to look exactly like that. Okay, like some people I know prefer to write it more horizontally. That's why I had the two methods. I didn't need to show you that, but you could write it out more like this. Just make sure you're showing me where the 8 goes, where the 2 goes. It's not like I'm asking for a lot of extra work or steps. It doesn't take long to show that. Just do it. I'm going to expect it. Okay, now the other way I said was a table. And this option is available to you. So take that rectangle and just split it up. I just did a little 3x3 rectangle here. Top row I intentionally made a little thinner because this is just the heading row. These are the headings that we use when we have one of these equation tables. They all essentially look the same. First column, operation on, I put X. I probably should change that and put M. You can leave it at X. It's just the operation on the variable, but since in this equation the variable is actually M, it doesn't matter. I would never mark it wrong if you put the wrong variable right here. It's not a big deal. And then the middle column is your inverse column, your undo column. And then over here on the right, up here, we're going to have our M equals column. Now this method is different looking, but it's the same process that we always follow. It just organizes the steps in a little bit different of a fashion. So if I asked you, if I told you what M is, like if I said, okay, M is 10, in this equation, said, okay, test it. What's the first step you would do if I told you the value of M in order to test it? Grace? Yeah, you take that value and multiply it by 2. And that's what would go here in this first cell. So the operation on M, the first thing that's being done to it is that it's being multiplied by 2. How would you undo multiplying by 2? Sydney? Divided by 2. Okay? The other step, I'm going to leave that third column empty right now. The other step, after you multiplied it by 2, then what are you going to do? Alex? Add 8. So we would put here plus 8. Alex, what's our inverse there? Subtract 8. The isolated value right here, this 32, which, by the way, 32 is not the answer. I get people, and it's normal. You think, okay, 2M plus 8 equals 32, and kids are talking about this, and they'll say, yeah, you know, like, since 32 is the answer, then I did this and did that. The answer isn't 32. The answer is whatever, what is? Whatever M is, exactly. 32 just happens to be the term that's isolated. So let's not refer to that as the answer. It's just the term that's isolated. That term goes out here in the bottom right-hand corner. So now it's set up. We sometimes call this method the zigzag method because you take this term right here and you apply this operation to it and you put the answer up in this cell here. 32 minus 8. We've done this already. 24. Take that cell, apply this operation. The value goes up here. 24 divided by 2. M is 12. So you've organized the table in a way that when you work from the bottom up, you've worked backwards, which is how we solve equations. And it just works itself out. You've done the same operations. We skip back here. The first thing we did was 32 minus 8. Well, that's the first thing we did here. The next thing we did was 24 divided by 2. That's what we did here. So it's the same steps, just looks a little different. Okay? If instead of well, exactly. If I had let's say I had something like this, right? I had x over 2 plus 6 equals 10. I don't know, I'm just making this up, okay? This operation here is divide by 2, right? So in our table, the first thing you would put here is divide by 2. So then in this column, that's where you would have the times 6. That would be the inverse of that. Okay? Okay? I want it to be, it doesn't have to look exactly like this. Now, if you're going to use your own method, I assume it's going to be more like the algebraic way where you show your work. I just need you to make sure you show where everything went. Like, why did the 8 just go away? Why did the 2 just go away? It doesn't have to look exactly like mine. I just need you guys to justify why it went. Okay? I've just found that over the years, this is pretty organized. You'll get into the habit of doing this because we're going to get into ones that have many steps, 5, 6 steps. And you want to have a system in place because otherwise you're chasing numbers all over your paper and it gets ugly. And then I'm chasing numbers all over your paper, and I'm not very good at that. So just try to help me out with that. All right, the next one, example 2, you have your choice. If you like that table way and you want to give it a shot, go ahead. If you'd rather do it the algebraic way, do it that way then. Not that I care, because I don't care which method you prefer, but just out of curiosity, how many of you chose to go the route of the table method? Okay. So then the others took like some sort of algebraic approach, I assume, to doing it. Good. So what I'll do is I'll just start this off, and then somebody that did the table can tell me how to fill this thing in. And then somebody who did it algebraically could then, your answer is going to be the same as their answer too. So here's the table. How did you fill it in? Go ahead, Sean. Okay. Okay. You don't have to do these arrows, by the way. Go ahead, Sean. Good. Okay. Algebraically. Can somebody talk us through how we would take this thing apart? Go ahead, Grayson. Okay. Okay. Very good. Notice the steps are the same. Sean said the first thing he did was take negative 33 plus 5. That's what Grayson did here. And then they took the negative 28 divided by 4. It works. All right, turn that over. Let's try a couple little bit more challenging ones. Example 3. Yes, we still have fractions. Haven't forgotten about these guys. So if you want, you can break that rectangle up into a table. If not, just try it out correctly. And then try number 4. Number 4 has an extra element to it that we have not seen yet, so I just want to see how you do on 4. How many of you have a value for W figured out? Okay, great. Tell me let's just go algebraically just to speed this up. So first step that you applied here, if you did it algebraically, what's the first thing you did to isolate? Sarah? Huh? Okay, so I'm left with 1/4 times W equals 3, and this goes back to our one-step equations from earlier last week. Okay, what would we do here then? Yeah? And we've talked about this rule. Dividing by a fraction is the same as multiplying by the reciprocal, right? So this is like saying 3 times 4/1. So this is why W is going to have a value of 12. Because if you take 3 and you break it up into 4 parts, or divide it by 1/4, I should say, you're going to get 12 of those pieces. So it's going to be 12. Now this next one, I don't know that we'll get through it all, but there is something different about this equation than we've seen to this point. What do you see, Yaman? What's different about it? Yeah. So can we do something about that? What would you do? Well, this is a C, though. So did you combine these two together? Oh, you wrote it. I got you. Got you. Go ahead. So this is actually saying 4 plus negative 6C equals 58. That's what you're saying. Good. And that's exactly what you need to do. If you identify that there are like terms on one side of the equation, your best bet would be to simplify that. Combine them. Now you're in a 2-step equation. This is technically a 3-step equation because you could do step 1, and now we have 2 more steps from here. And I know this looks odd to people. Whenever the variable's not first, for some reason, it doesn't make sense. So if you want to reverse this, since it's addition, you could write this as negative 6C plus 4. You're well within your rights to do that. Might help you see it a little bit better. And then you just start taking it apart from here. What did anybody get a value for C? What'd you get, John? Not 5 and 1/6. This one actually works out to be an integer. Gina? -9 is what it would be. Let's look at it quickly. Inverse of adding 4 is taking 4 away. So now I have -6c is 54. Then what, Brock? Divide by -6. There you go. Good. C is -9.